This conference will now be recorded.
Hi everyone. In this video, I am going to explain the topic formation of partial differential equations. Outcomes. After the completion of the topic, student will construct a partial differential equation by eliminating arbitrary constants. Also, student can construct a partial differential equation by eliminating arbitrary functions. We do formation in two ways. First one is by eliminating arbitrary constants. Second one is by eliminating arbitrary functions. First we study by eliminating arbitrary constants. So we'll take an example. Form a partial differential equation by eliminating arbitrary constants from z equal to ax plus by plus a square plus b square. Remember, in this unit, we have restricted to a dependent variable z and two independent variables x and y. What is important here is count of independent variables. Remember, throughout this unit, number of independent variables are 2, which are x and y. And we have taken an equation. Using this equation and by doing elimination of arbitrary constants in this equation, and by doing partial differentiation, we are going to form a partial differential equation. Now coming to the solution, start with the given equation z equal to ax plus by plus a square plus b square. Take it as equation 1. Now to get a differential equation from equation, first of all we have to differentiate that equation. Now let us differentiate 1 with respect to x partially. So equation number 1, left side is z. When we differentiate z partially with x, we write dou z by dou x, which we indicate with p. Right side, when we differentiate each term, first term a into x, when you differentiate a into x partially with x, a is constant, that remains. Derivative of x with x is 1. So what we get is ax will reduce to a after differentiating partially with x. Then second term, here b is constant, and remember, while doing partial differentiation with x, we have to keep y as a constant. So b constant, y constant, so this complete term become constant and derivative of constant is 0. And the other terms a square b square being constant terms, derivative becomes 0. So after differentiating partially with x, we get p equal to a. In the same way, if you differentiate 1 partially with y, we get q equal to b. So in 2 we are having p equal to a, in 3 we are having q equal to b. Let us use 2 and 3 in equation 1. So substituting p equal to a, and in fact we substitute a equal to p and b equal to q in equation 1, and this is the equation we get, which is z equal to px plus qy plus p square plus q square. So which is a required partial differential equation of first order. Remember, now in this equation 1 we are having two constants. By eliminating two constants, which order equation we get? First order. Now let us take next example. Equation is x minus a whole square plus y minus b whole square plus z square equal to 25. So start with the given equation. First we differentiate partially with x, equation 1. When we differentiate partially equation 1 with x, we get x minus a equal to minus z into p. In the same way, when you differentiate 1 partially with y, we get 2 into y minus b plus 2z into q equal to 0. From here we can write y minus b value, which becomes minus z into q. So we can use this 2 and 3. So here 2 contains x minus a value and 3 contains here y minus b value. We can use this 2 and 3 in equation number 1. With that we get this equation. So once again we get a partial differential equation of first order. So even in this problem we are having two constants. By eliminating two constants, we get first order equation. Now continuation, let us take this time a problem with three constants a, b and c. Now again the same procedure, we start with given equation, we differentiate 1 with respect to x partially, so we get equation 2. Again, differentiating 1 with respect to y partially, we get equation 3. Now, if you closely observe 1, 2 and 3, it's not possible to eliminate constants a, b and c. For that reason, we have to go for second order derivatives. So here I've taken equation number 2. So this is our equation number 2. So now I am going to differentiate this equation 2 with respect to x. After differentiating with respect to x, this is the equation we get. And in this, r is nothing but dou square z by dou x square, remember. Now I'll go back to second equation and I'll rewrite the second equation like this. After rewriting second equation, we get c square by a square value. And from 4, again I can obtain c square by a square value. So if you compare 5 and 6, LHS part is same, so I can equate RHS part. After equating RHS part, this is the final equation we are getting. And if you notice, there is a second order derivative, dou square z by dou x square. And so that's why this required equation is of second order. So by eliminating three constants in the problem, a, b and c, we obtain a partial differential equation of second order. Now coming to the important points to remember. First point, if the number of arbitrary constants to be eliminated is equal to number of independent variables, we obtain a partial differential equation of first order. What I mentioned to you earlier is number of independent variables are 2. And in first two problems, we have taken problem with two constants. So two constants with two independent variables, remember we get first order PDE. On the other hand, if the number of arbitrary constants to be eliminated is greater than number of independent variables, in last problem constants are 3 and we are having two independent variables. So we get into this condition, greater than condition. So that's why we got a second order PDE. So remember, when you get constants number greater than number of independent variables, we obtain a PDE of second order or higher order. So this is about formation by eliminating constants. Now we'll see formation by eliminating arbitrary function or functions. In this example, we're having a equation z equal to f of x square plus y square with one function. Now let us see the solution for the problem. Given equation is z equal to f of x square plus y square. After differentiating one with respect to x, what we get is derivative of z partially with x is dou z by dou x, and it is indicated with the p. For f, its derivative is f dash, and for x square plus y square, derivative is 2x. Since y being a constant and derivative of constant is 0. Similarly, if you differentiate partially with y, we get dou z by dou y, which is q, f dash of x square plus y square into 2y. Now if you closely see equation 2 and 3, there is a possibility to eliminate the function. How we can eliminate is, we can divide equation 2 with equation 3. When I divide 2 with 3, left side we get p by q, right side after cancellation of f dash and 2, we remain with x by y. So after rearrangement, this is the equation we get, py equal to qx, which is required partial differential equation of first order. Now what you have to notice is, in this elimination of functions, by eliminating one function, we get partial differential equation of first order. Now let us take a problem with the two functions now. In this problem, we are having two functions f and g. Let us see what happens. So this is the given equation. So differentiating first time with respect to x, we get equation number 2. Again differentiating with respect to y, we get equation number 3. But using 1, 2, 3, it's not possible to eliminate the functions f and g. So whenever elimination is not possible, we have to go for second order derivatives now. So I take second equation and I have differentiated with respect to x partially. So when you differentiate dou z by dou x, you get dou square z by dou x square, which is indicated with r. So for f dash, derivative becomes f double dash. For g dash, derivative becomes g double dash. And again, I take third equation and I differentiate partially with y now. When I differentiate dou z by dou y with y, I get dou square z by dou y square, that is indicated with a t. So after differentiation with y, we get equation number 5. And if you see right side part of equation 5, I can take minus sign common. After taking minus sign common, what is remaining is f double dash of x plus iy plus g double dash of x minus iy. And if you go back and see equation number 4, that is nothing but r. So that I substitute here. So t equal to, in place of this right hand side, I write minus r. And if you combine the terms, you get r plus t equal to 0. If in full form, r plus t is nothing but dou square z by dou x square plus dou square z by dou y square equal to 0, which is a partial differential equation of second order. So what you should understand from this problem is, by eliminating two functions, we get a second order partial differential equation. Now this is the point you should remember while doing elimination of functions. That point is, number of arbitrary functions to be eliminated is equal to the order of the partial differential equation obtained. So what we have studied in this video is formation of partial differential equations, and we can do formation in two ways. One, by eliminating arbitrary constants, and second way is by eliminating arbitrary functions. Next is a assessment for you, a problem on order and degree of a partial differential equation. This is the first problem. Second is a problem on elimination of arbitrary constants, two constants problem, and a problem on elimination of functions. In this problem, it contains one function. You know, one function, by eliminating one function, which order we have to get? We have to get first order. Next, there is a problem with two functions f and g. And last one is by eliminating a problem by eliminating arbitrary constants, and it contains two constants. So this is the assessment for you. And in the next lecture, we study linear partial differential equations of first order.